Okay, so it looks like we're on lesson 7, rational equations. Okay, so now instead of just doing the operations on the expressions and then leaving it, we're now going to start doing e equations, rational equations. Okay, so what you can do on the calculator is solve the equation using technology. Okay, and this is something a 30-2 student would be expected to do just using technology. But in the -1 stream, you have to be able to show how to do this algebraically. Okay, so you can see how they're going to do this. And this is true for all equations. So you can just make a generality and write this note down for all equations can be done this way. Okay, doesn't just have to be rationals, could be radical, could be anything. Okay, you put the left hand side as y1 and you put the right hand side as y2. So the right hand side just type in as y2 and the left hand side type in as y1. And I'll show you how to do this with the brackets. Alright, so let me just whip up the calculator. So start typing, just make sure you use brackets for the, what I use is the brackets for the numerator and the denominator just to be super careful. So we got a numerator 1 divided by a denominator 1. And I like to put the numerator and denominator separately in brackets. Just keeps me organized and careful. Now I'm adding the next expression, which is a +1 divided by a x minus 1, all in brackets, separating numerator and denominator. Jump down to y2, and y2 is 2. Okay, so the first function is going to look really crazy to you. You guys probably haven't seen rational graphs before. And then the second equation is just going to be a constant line at y2. So for every x, y is 2. So when you graph that, and I'm just going to hit zoom 6 so I have a standard window. So there's the craziness of the rational. Okay, and there is the y cutting across. So where do you suppose the answers lie? The intersects. So again, with this window, it's kind of hard to see. So I'm just going to maybe live with it. You could also change the window so you see less y. Maybe that would be more optimal. Less y. Let's cut it down to 5. Okay, so it looks like we have an answer here, where my pointer is, and an answer here. Now, there are some vertical bars on this calculator that don't actually exist on your graph. Does anybody know what those are? Do you know where they're located? So this vertical bar, where is it located? At x equals what? -1. What's one of the non-permissibles? -1. And where's the other vertical bar lie? At +1. So there's another non-permissible there. Okay, and I'll sketch that for you more appropriately on your window. Okay, so looks like there's an answer here at x equals 0 and over here around x equals 2. So you can also use the table second graph. Well, my window's away at 68, so I'm going to go table set, start at 0, second graph. Okay. So do you see how the y1 is all the randomness of that other graph, and then y2 is constantly 2? So why does it say error? That's the NPV, right? Where's the other NPV at? -1? And then you can see another error there. And what do you see when x is 0? Both 2. And x equals 2? Both 2. So whenever you have the same answer, of course the left side would be 2, the right side would be 2, and of course that's the x value that solves this equation. So there's two answers to this, 0 and 2. Okay, so let's go back to our lesson. And let's try and sketch this out. Okay, I believe there was something like this going on. And then there was some craziness like this. And then there was something like this. And then 2 cut across. That's a pretty bad drawing, but 2 cut across like this. So I'll sketch that in for you. Here was y equals 2. And we had 2 answers. x2, y2, and this answer was x0, y2. Okay, and I'll also get you to sketch in those non-permissibles. To sketch in the non-permissibles, you need dashed lines. So something like this. And we'll talk more about those non-permissibles in a second. And it's just sort of a rough sketch. It's not perfect. Like the black lines of the graph should never cross over those pink lines. We'll talk more about that shortly. So it's not a perfect drawing at all. Just sort of getting the idea of what's happening. Okay. So this x-intercept method, I'm just going to show it to you briefly, and then you can either use either or. I never use the x-intercept method. I always use the intersection method, so I'll show you both. For the x-intercept method, you just bring the 2 to the other side, and then what do you notice? It switches signs, and now you're equal to 0. So you put everything on one side equal to 0, and then you solve for the 0 using the 0 feature. Okay, so it's a little bit different. Okay. Now, of course, solving for it graphically is just going to be a check for you guys. Solving for it algebraically is the ultimate goal here. Okay, so if you struggle with that calculator, we can talk about that one-on-one, but like 90% of my focus is going to be on solving it algebraically. Okay? So before we go into this, I don't think... Okay, let's just read it and see if we can apply it. If the equation consists of a single rational expression on each side, then use cross multiplication to simplify. So put a star on this, and it's exactly like number 1b, and it would just look like this. A over b equals c over d, and they're saying that you can just cross multiply. So what does that mean? We don't want any denominator. So those guys times and those guys times, and you'll get this. A goes with D, B goes with C, and you have no denominator. Okay, so imagine you're trying to solve for an unknown quantity, x, and it's in the bottom. That's a problem, right? If it's in the bottom, you have to move it to the top. Okay? Alright, so next. So you're going to see this lots. Okay, so that's why it's given its own like 1a, or step 1. So you'll see this cross multiplication lots. And you guys want to do one right now? Since we just talked about it, let's just do one. So what are we timesing? 5x plus 2, and be careful about brackets. You're multiplying that whole term. And 2x plus 1. You with us back there, Kyle? You with us? Okay, so multiplying the 5 in, you get 5x plus 10. Multiplying the 2 in, you get 2x plus 2. And then you're laughing because this is very basic stuff, like junior high stuff. Get the x's on one side, the number on the other. So subtracting 2x, I have 3x. Subtracting 10, I have negative 8. You guys okay with that? I'll use my pointer just in case. 2 came over here, 5 becomes 3. 10 comes over here, 2 becomes negative 8. And then solving for x, divide out 3. So it's 8/3 negative. This is the solution to this. Bizarre, right? Like, just some random number, 8/3. Okay. Also, check NPVs. We did this. We did this with those. What were they called? Radical equations. You remember? We got our answer and we had to check it against the values that weren't allowed. Okay. So again, doing that again. So non-permissibles, x is not allowed to be -1 and not allowed to be -2. So this is okay. This answer is okay. Okay, it's good. Okay, so let's look at step 2. If the rational equation has more than one term, does that look like A? More than one term on either side. So highlight that whole thing. More than one term on either. That looks like this. It says, consider multiplying each term in the equation by the LCM. That's an interesting strategy. Okay, so let's take a look at this. It would kind of be like A plus B over C equals D plus E over C. That's what this looks like in general. So what would we do here? Multiply by LCM. So what's the LCM for this? C. So let's times all this by C, and let's times all this by C. And what's the effect? What's going to happen? I just put a star by it. The C's will cancel and you'll have what? No denominator. Yeah, this is the goal. No denominator. Okay. So, what are we going to multiply everything by? Okay, good. Okay, so let's put a big bracket around each expression and multiply by x. Understanding that when you multiply the whole side by x, every term is getting that scale. You're getting scaled by x. So you end up with 4x plus 2 and 7x plus 3. Now dumping everything to, or the x's to one side, where should the x's go? To the right, it would stay positive, so 7 minus 4. And put the 3 to the other side, so 2 minus 3. And then divide it out. So here's your answer for x. And checking non-permissibles, x is not allowed to be 0. So when x stands alone as a monomial, x not allowed to be 0 when it's in the bottom like that. Okay, question 3. Strategy 3. Use previously learned skills. Oh, okay, that's awesome. So we got to know our quadratics, because we all should be good at linear by now. Always be aware there are domain restrictions. This is step 4. When dealing with rationals, and check your solutions accordingly. We've been doing that. So we've been doing that. In other words, when verifying, note that the solution cannot be a non-permissible. Again, that's this as well, since this would divide by 0. So basically, it's steps 1 and 2 in this page here. All right. Next page. Okay, when you look at the class example 2a, what do you see? Is it like number 1 or number 2 in those steps? No. Why is it like number 1? There's no extra terms, right? It's one term equals one term. So in this case, you can cross multiply. The cross multiplying, all it is, it's step 2. Because step 2 is, what does step 2 say? Multiply by what? The LCM. So what's the LCM for the denominators here? What is it? It's the product of both, right? So that's the LCM. So what happens when you put this LCM and you multiply by both sides? Hey, no worries. Aaron. So we multiply by the LCM on both sides. Okay. And what do you see happening? The 3x plus 5's cancel. The 2x plus 3's cancel. And what basically happened? What was left there was this guy came up. And what was left here? This guy came up. So cross multiplying is multiplying by the LCM. It's not magic. It's the same strategy. Okay? So you're basically multiplying by the LCM at all times. Okay? So let's just rewrite this as if you cross multiplied. And then it says in step 3 you got to rely on previously understood skills from quadratics. So in this case you have to distribute properly. Now I marked your guys' test over the weekend and there was 2 people that still don't know how to do this. Okay? They're forgetting the middle term. So some scary stuff. So you distribute these binomials, you make sure you get all of them, okay? 12x squared minus a 6x plus 20x minus 10 equals. Alright, you don't screw that up, okay? That's taught in grade 10. Used to be taught in grade 9. And halfway through grade 11, there's some of us that still are forgetting this. So don't let that be you. Next one, 12x squared plus 18x minus 2x and minus 3. What do you notice about the middle terms always on these? Not disappear, but collect. The middle terms always collect. So just a cleanup step here. So minus 6 and a plus 20. And on the other side, what cleaned up was a plus 18 and a minus 2. So okay, now at this step, we have to recall back a few lessons or a few units ago. Pardon me, a few units. How do we solve quadratic equations? Move it to one side so that it's 0 on the other side, right? Now, does it matter which side we move it to on this one? Why? Yeah, good. So if the x squares, let's just say this one on the right, let's say this was 13, which way would you put it? Put everything over on the right, right? So that this guy's positive. We like the x squared positive. Okay, so nevertheless, the 12s are going to cancel. So which way do you want to put it? Does it matter? Let's go to the right. 16 is bigger than 14, right? So let's go that way. Put everything on the right. That means the left is 0. Good. So the left is 0. So we have, and I'll just to see this, we'll go minus 12x squared minus 14x plus 10. And we have 2x and a plus 7 equals 0. Can that be factored? So what's the 0 product rule? Cover up the 7 halves, negative 7 halves. Do you guys recognize this? So imagine the 2's not there, it would be negative 7, divide out the, you could also do it by longhand, negative 7 over here, divide by 2. So negative 7 halves equals x. Yes, sir. 7x plus 7? Yeah, you put negative 1, yeah. Yeah. Okay, so check the NPVs. Was 2x plus 7 one of ours? No, so it'll work. It'll work. You just have to check it against the NPVs. I'm looking at the key here, and they have like, they actually plug in -7/2 here, which would be, you know, pretty nasty. Do you want me to show you how to do that on the calculator? Here, I'll show you guys a technique here that is nice. Okay, so everybody type -7 divided by 2, hit enter. Everybody done that? Make sure you hit enter. And now the next line is blinking. See bottom left here, store, STO. See it? So you're just going to assign a letter to this value. So hit store and then X. Make sure it says answer X and then this. Now watch 4x minus 2. And I'll put it, I was going to do it in 2 steps, but I'll do it in 1 step. 4x minus 2. You might have to start over. 4x minus 2 divided by 2x plus 3. Okay, I got 4. Okay, now try the other side. 6, I'll put it in brackets, 6x minus 1 dividing 3x plus 5. Also getting 4. So what does that tell you? That the left side equals the right side, so that number is the correct solution. So now you have a nice little trick on your calculator that will help you verify. Okay, let's do the next one. Okay, the next one has a little bit of a different scenario, yeah? What is, it's like scenario 2, right? So what do we have to multiply by? Multiply by the LCM, good. And the LCM will be, for the most part, if there's no monomials, it's just the product of all the binomials. So the LCM here will be t plus 1 and t minus 3. And let's go ahead and do that now. So t plus 1, t minus 3, and remember that that's getting multiplied on this whole thing. So we distribute there, and we will distribute there. And on the other side, you're just multiplying by a single number, so that's simple over there. Okay. Is everybody cool on that so far? Okay. So let's multiply through on the first term. What's canceling? The t plus 1 term. So you'll be left with 5t minus 2 multiplied by t minus 3 subtract. Whoop. Sorry about that. Not sure why that happened. Now let's do the next one. Subtracting. What cancels on the second product? The t minus 3 term. So what will be left is 2t minus 1 times t plus 1. Now the right hand side, we're just going to rewrite it. So what do you think about all this? What's the strategy now? Distribute, collect like terms, solve for t. Alright. Also, do you see that there's a minus between these two products? So you have to calculate each product separately and then subtract. So let's do that. And let's try to do these FOILs, these distributions, cleverly. Okay, what's the first term? 5t squared. What's the last term? 6. Any questions on that? How did it get to 6? How'd to get the 5t squared? Okay, now do the outer and the inner at the same time. Minus 15t. Everyone's got that? Minus 2t. Minus 17t. Now the next one. First one is 2t squared, and the last one is minus 1. Now how does the middle look? 2t times 1, 2t, minus t, plus t. Notice my t's with the hooks. T's look like plus signs, don't they? I always hook my t's at the bottom so they don't look like plus signs. Now the second, or the right hand side, do I put the 3 into both? Or I could put it in the second one. You just don't put them in both. Okay? Doesn't matter which one you put them in, just don't put them in both, because that's like multiplying by 9. Yeah. You can put the 3 at the end as well. You want to do that? Okay. This foiling is really easy because it's 1 times 1t, 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 so this is t squared, minus 3 at the end, and then you just go minus 3 plus 1, minus 2t. Keep saying 2t, it's kind of, I don't know why that sounds funny to me. Okay, so left hand side, when you're subtracting, remember that this negative gets subtracted onto each one, right? All those signs are going to change. So you have a 5t squared minus 2t squared. You have a minus 17t minus t. And you have a plus 6 plus 1. And I'm going to circle that one because that's the common mistake. See this minus, minus. Okay. And on the right hand side we have 3t squared minus 6t plus, oops, minus 9. Collecting like terms on the left, not touching the right, even though I could. Yep. Just take things slow and easy. And what do you notice again with the lead coefficient? They're going to end up canceling. That's not always going to happen, okay? They have cleverly created questions in this first section that always end up linear. Now in part 2, lesson 8 tomorrow, they're not going to end up linear. Which way do you want to dump it? Is it even going to matter? Dump it to the right. Stays positive. So negative 6t plus 18t. Is that 12t? Negative 9 and then negative 7, negative 16. What could you factor out of that? 4. And you get 3t minus 4. So what's the answer here? T equals 4/3. Check it against the non-permissibles. T is not allowed to be negative 1 and positive 3. So this will be okay. Alright, let's contrast class example 4 or 3 to the previous class example. What's different and what's the same? Say that again, buddy. Division thingy. Oh, it's not equal to a number, it's equal to a rational? Okay, good point. Yeah. Anybody else want to look at that? There's a what? Okay, so C2x plus 3. What's the same about that in class example 3? This, right? They're just binomials? Yeah, what's different about this? It's not what? Good. It's not factored. So that's going to be your first step, or else it's impossible to get the LCM. Okay, so 1 over x minus 4 plus 2 over x plus 4 equals 5 over x minus 4 x plus 4. So first step, factor. Okay, so be aware, if you're given an expression that's not factored, you must do that. Now, staring at this question, what do you believe the LCM is? X minus 4 times x plus 4? So do I need to multiply that on both sides? Yeah. The LCM, that's what the strategy said, multiply on both sides. That's the for sure way. You're sort of not the best at math, you're sort of just looking for a strategy or an algorithm or a process. This is it. Find the LCM, multiply it on both sides. So what happens when it comes on this side? So that's beautiful. That like makes my insides happy because there's like so much less work to do, right? Yeah, like it's a blessing. Now on the left hand side, this looks a little bit more nasty, but let's take a look. X minus 4, x plus 4 around the whole thing, and you have to distribute. I would recommend that you write all that. It'll help you stay focused on the task at hand. So as it comes in on the first term, what's going to happen? The x minus 4's cancel and the x plus 4 gets multiplied by the numerator, which happens to be 1. Then we're going to plus, or I want to use black ink. Is everybody okay with that? Follow my pointer. This whole thing is coming in on the first guy. These two terms multiplying on the first guy. The x minus 4's cancel and you're left with 1 times x plus 4. Plus, what's the next one going to be? 2 is this second term, and you're multiplying it by there. And which one gets cancelled? The x plus 4, so you only be left with x minus 4. Now what do you notice about this step? What is not there? Yeah. No denominator. So that is ultimately your goal. However you get there, as long as it's algebraically fine, you're good. You're good to go. Now, how to solve this basic stuff? Distribute, collect like terms, and solve. So we are multiplying by 1, multiplying by 2. Now what? Collect like terms. So there's 3 x's on the left. What's on the right? Start at 5, subtract 4, add 8. Jordan saying 9? Divide by 3. Okay, NPVs. What is x not allowed to be? Plus or minus 4. She's quick on that. So 3 is not plus or minus 4, so we're good. You could also verify with your calculator like I showed you. Okay, you're done. Far as your homework is considered, number 1 is practicing your calculator. So number 1 is only for those interested in getting good at the calculator. you're going to have a hard time sketching them. So if you're pressed for time, in number 1, just try to solve for the answers. Don't worry too much about the sketches. So rational graphs comes later in the year. So there's not going to be sketches. So don't worry too much about sketching those. Yeah, it comes later. Okay, so all of number 2. So you can do number 1, no sketches if that's what you want. You could sketch, I mean, it's your choice. Number 2, all. And if you were looking for only just to do 2 of them, do A and B. But I would recommend all of them. There's even some on the back page. Okay, so most of your work should be spent, most of your time should be spent with number 2. 2 and 4. 4 is like the one we just did. So 2 and 4 if you're trying to do the bare minimum, okay? And if you got time and you want to work, do it all. And then when tomorrow's lesson's identical, except the way that we solve them at the end is a little bit different. And don't skip Wednesday's class. It's a tough lesson. Practice test on Thursday, and then we're writing on Friday, right? You guys have seen this. December 6th is this Friday? It's Tuesday? So you're lucky. So Friday, Monday are review classes. I'm going to review. And we'll do quiz catch-up. Yep. Yeah, I'll print your marks, yep.